This is lesson 2.1 in elementary algebra. It's called simplifying expressions. So this is the first lesson in chapter 2. And what we're going to do when it talks about simplifying expressions, it usually means that we're going to combine things in an expression, in a list of numbers and letters, in order to make it look prettier, simpler, less messy. So a couple of the things that we need to go over in order to simplify is to learn what similar terms are, or what we call like terms. If I have 3x plus 4x, those are two terms, and terms are a group of letters and numbers separated by a plus or a minus sign. At least that's the definition I'm going to give you right now. So I have two terms here. Now whether or not I can combine these has to do with two rules. They both have to have the exact same letters, and this has an x and that has an x, and the number up here, the exponent, must also be the same. So in this case, whenever there's no exponent up here, it's always a 1. And there's a 1 there, so it doesn't exist. So as long as we have the same letters and the same numbers as exponents, we can combine these. And when we combine these, when we add or subtract them, all we do is add or subtract the number. 3 plus 4 is 7, and we tag on the letter afterwards. If I had 3xyz plus 16xyz, I have like terms because all the same letters and all the same exponents, so I just add the numbers and tag on my letters at the end, and I'm done. Alright, so if I have numbers like 3x squared y plus 3xy. The question is, are these like terms? Is this one like this one? Well, they have the same letters, x and y, same letter, x and y. Difference is this has a 2 and this doesn't. So that means they are not like terms, which means we can't combine those. So if somebody says simplify this, you're going to say, nope, can't, it's already simplified, that's as far as I can go. So it has to have the same exponents on both the letters. So if I put a 2 on here, and a 3 on here, and a 2 on there, they're still not like terms. Even though my x's have 2's, my y has a 3, and that y has a 2. So because that is not the same, I can't combine anything here, and that's all I can do. So those are really, really important when you're doing these. So let's go ahead and start with example number 1 here. And example number 1, that gives us a couple options. We have 3x plus 4x, and that is going to be, we're just adding those together, and we get 7x. When we have 7a minus 10a, again, we're just subtracting, and we get negative 3a. And part C is 18y minus 10y plus 6y. Okay, so again, we have the same letters and the same exponent, so I can combine these. 18 minus 10 is 8. 8 plus 6 is 14, and again, I tag my y on to the end. Alright, so let's look at some that are not like terms, so you can get into practice on what to do with those, because one of the things that you're going to learn is sometimes it's okay to have messy when you're doing these. So let's have 3x plus 5 plus 2x, whoops, and we'll put minus 3. Alright, so given all of these terms here, some of them are going to be like, some of them aren't. So 3x and 2x are like, and what I'm going to do here is I'm going to put a box around those. And I include in my box the sign in front so I know what to do. Alright, now I look at the other numbers I have. I have a 5 and a minus 3. Those are like terms because there's no letters. So when you don't have letters, you automatically know that they're like terms, and we can combine those. So let's combine the 3x and the 2x, and I get 5x. And let's combine the 5 and the minus 3. 5 minus 3 is 2. That ends up being your solution. So we went from 4 terms down to 2 terms. So we did make it simpler. We did simplify. So let's go ahead and look at example 2, and let's do letter C. It says 5 x plus 8 minus x minus 6. Okay, I like to put these little boxes and circles around there, and of course I have colors, so mine look pretty and a lot different than yours will when you're just using a pen or a pencil. I'm going to circle that. So I'm just doing all the like terms so that they're similar in color and shape. Alright, so I'm going to take my 5x minus 1x and get 4x. And I'm going to take my 8 minus 6 and get a 2. So my answer is 4x plus 2. So, should give you too much trouble. Finding like terms and combining them is all we did there. Alright, so we're going to go to the next section of this 2.1 called Simplifying Expressions Containing Parentheses. Now, hopefully, over the years, you have learned PEMDAS. PEMDAS means you do everything in the parentheses first, then you do the exponents, then the multiplication and division from left to right as you see them, and then the addition and subtraction from left to right as you see them. So that takes us to example 3. We have 5, and we have in parentheses 2x minus 8, and then we subtract 3. So what we do is in the parentheses first. That's what this P stands for. Are those like terms? No, that has a variable, and that does not. So we cannot combine those. So what we do is we do what's called distributing, and that's where we take this outside number that's being multiplied by this parenthesis and take 5 times each term. So we're going to take 5 times 2x, and then we're going to take 5 times negative 8. And then we're going to tag the 3 on. So what that did, by distributing that 5, it took the parentheses off. And then we're left with this. Do we have any like terms there? Well, yeah, we sure do. These right here are like terms because they don't have any letters. So I end up with 10x, a minus 40, minus 3 is negative 43. I'm assuming you know how to add and subtract negative numbers at this point. If you don't, holler, and I'll help you with that. So let's do example 4. We have 7 minus 3 times the quantity 2y plus 1. Okay, we're going to distribute again. And negative 3 times 1 is negative 3. This is a negative sign. Oh, why don't I just erase it? There, and put a new one there. Alright, so, like terms, 7 and minus 3. Because I don't have any variables, those are my like terms. So 7 minus 3 is 4, minus 6y. There's nothing to bring that 6y with. And usually we put the variable first. So I'm going to take the sign and the number, put it first, and put my 4 last. And that's more of the correct way of doing it. When I get to one like example 5, I have 5 times x minus 2 minus 3x plus 4. Alright, so we're going to distribute the 5 right here and get 5x minus 10. And what we've got here, we've got a minus sign. So when we have a minus sign in front of a parenthesis, so our goal is to take the parenthesis off. But in order to take that parenthesis off, I take this minus sign and distribute it. Or, in other words, what I do is this minus sign means that everything inside of here changes sign. So this 3x is a positive. So I make it a negative. And the 4 is positive, so I make it a negative. And notice what happened. The parentheses came off. So actually what I did in theory is this is actually a minus 1, and I distributed that negative 1 to each of these. So negative 1 times 3x is negative 3x. Negative 1 times 4 is negative 4. So that's what really happened. But you don't have to know all that theory in order to do that. All you have to do is know that if you have a minus in front of a parenthesis, if you take the parentheses off, you just change the sign of everything in here to its opposite, and you're good to go. Alright, so now I've got a 5x and a negative 3x, which is 2x, a negative 10 and a negative 4, which is a negative 14. And when you do that, you're done. Okay, so that's example 5. Continuing with lesson 2.1, we jump to example 7. And what they've done here in example 7 is they give you an expression like 2x minus 3y plus 4. And they said, okay, 2x minus 3y plus 4, let's pretend that x is negative 5 and y is 6. So what we're going to do is we're going to put a negative 5 in for x. Notice I always put it in parentheses. Minus 3, and what we say? Y is 6 plus 4. And then I just solve this. 2 times negative 5 is negative 10. 3 times 6 is 18 plus 4. Negative 10 minus 18 is negative 28 plus 4. Negative 28 plus 4 is negative 24. And that's what I get when I put negative 5 in for x and 6 in for y. Now let's look at example 8. I have x squared minus 2xy plus y squared. And I've said that x, that doesn't look like an x equals 3 and y equals negative 4. Okay, so let's do that. 3, again I put it in parentheses, minus 2 times 3 times negative 4, and for y, plus negative 4 squared. Alright, 3 squared is 9, minus 2 times 3 is 6, and I'm just going to do one little bit at a time. Negative 4 squared is 16. 9, multiply this. Okay, notice what I did here. Very important. I did all the multiplication first. I multiplied 2 times 3 and got 6. Then I did this times this. I didn't do anything with the 9 or the 16. I always do my addition and subtraction at the very, very end. Now I don't have anything to do except add, so now I add. 9 plus 24 is 33 plus 16. 43, so 33 plus 16 is 49, and that's what I get for example 8. Okay, so that's it for that part. Let's jump into the last section of this lesson. It's called sequences. And sequences, there's different kinds of sequences. There's an arithmetic sequence and there is a geometric sequence. So let's see what they're asking us to do here in this particular one. For example 9, they're giving us an expression 2n minus 1. And they're asking us to substitute 1, 2, 3, and 4 for n. So let's start by substituting 1. 2 times 1 is 2, minus 1 is 1. Then let's substitute 2. 2 times 2 is 4, minus 1. Then let's substitute 3. 2 times 3 is 6 minus 1. And substitute 4. 2 times 4 is 8 minus 1. Okay, so when we substitute 1, 2, 3, and 4, what we get is the odd numbers, 1, 3, 5, and 7. So that is called a sequence. And we'll be getting into that more later on. Now I said geometric and arithmetic. Those are series. Arithmetic and geometric series. I was getting my S words messed up there. So sequences is just the order that things happen. So example 10 says fill in the tables below to find the sequences formed by substituting the first 4 counting numbers into the expressions. So what they did is they give you n, and n is just a variable, meaning this is the number we're going to substitute, and they want you to substitute it in for there. So if we put a 1 in for n, we're going to get 2 times 1. If we put a 2 in for n, we're going to get 2 times 2. 3 in for n, we're going to get 3 times 2. 4 in for n, we're going to get 4 times 2. So we get 8n, or 8. In the next one, instead of doing the n, they are giving us an n squared. So when we put 1 in for n, we get 1. When we put 2 in there, 2 times 2 is 4. 3 in, we get 9. And 4 in, we get 16. Okay, so it's just, again, plugging numbers in there. in replacing the variable, or in this case n, with the numbers, and they even tell you which numbers, 1, 2, 3, and 4. And you just plug those in and you're good to go. So that's it for problem or lesson 2.1 in elementary algebra.